Okay, so today we will start with hypothesis testing. So can you hear me clearly, Javadia?
Yeah, I can.
Okay, so what is hypothesis testing? So hypothesis testing, your hypothesis testing is an art in statistics where your analyst test the assumption test the assumption based on population parameter. Okay, so based on population parameter, your analyst test whether your assumption is correct or not. Then that is what hypothesis testing is. Say for example you can take is
Mhm.
100 random people, 100 random people,
Okay.
whether whether they had breakfast or not. Suppose we have 100 random people, and we need to see whether they had breakfast or not in the morning. Okay,
Okay.
in the morning, and we assume that okay, we guessed, and we assumed that 50% of the people had 50% of the people had breakfast. So you made an assumption, maybe like 50% of the people will had breakfast. Okay, so your based on this assumption, so based on this would be your assumption. Okay, so based on this assumption, we will do hypothesis testing and see whether this is actually true or not. So whether my assumption is correct or not. So whether my assumption is correct or not. For that, we do hypothesis testing. Okay, does that make sense?
Yes. Yes.
Okay, so yeah. So, and second terminology is your significance test. If the hypothesis makes sense based on sample data, it is called a significant test. Okay, so based on what does this mean is, right now we have concluded, we have a assumption that 50% of the population had breakfast right? So out of 50%, like we have made an assumption, we draw we draw a sample random sample of few people. Okay, for testing whether this assumption is correct or not. We draw For testing, we draw random sample of few people. Okay, and we set some test statistics and measure some threshold value. Okay, and if my threshold value lie within a certain significance level of significance, so the threshold value would be like, we need to have one value, threshold value, so that we can make an assumption like whether 50% of the population had breakfast or not. So that threshold value, so threshold value, okay, will be your level of significance
Okay.
So by looking at your level of significance, you can say whether you accept this assumption, your 50% had breakfast or not. Okay, based on the level of significance, we determine the test assumption. Okay.
Okay.
So for that, we draw a sample data from population. We draw a sample data and we see a threshold. And if the threshold, based on the threshold value, we determine, which is also called level of significance, we determine whether the test assumption is correct or not. So that is the level of significance. We will discuss that in more detail.
All right.
So in hypothesis testing, we have two things. So one is null hypothesis and one is alternative hypothesis. So in the previous example, if 50% had breakfast, so your null hypothesis will always be, it's 50% means 0.5. So null hypothesis is denoted by h naught, so will be 0.05, and your alternative hypothesis HA will be not equals to 0.5. This means your 50% population had breakfast and will be your null hypothesis. It will always be your null hypothesis. And 50%
Okay.
didn't had breakfast. Didn't had breakfast will be your alternative hypothesis. So why we use null hypothesis and alternative hypothesis? So that we can make our assumption, like we divide our data in a way so that we can test whether 50% of population had breakfast or not. So I will divide this proportion in two parts. One is on the basis of null hypothesis and one is on the basis of alternative hypothesis. Okay, so that's why we have introduced two concepts here, null and alternative hypothesis. So here in this example, null hypothesis will be 50% had breakfast. So null hypothesis will be h naught equals to 0.05. 50% had breakfast. This will be my null hypothesis. And
Mm-hmm.
alternative hypothesis will be 50% didn't had breakfast. So not equals to 15. This will be my alternative hypothesis. Okay. And null hypothesis and alternative hypothesis are always mutually exclusive. That means they are not dependent upon each other. This means not
Okay.
dependent dependent on each other. Okay. So we can take an example of a courtroom. Suppose, for an example, if an accused is innocent, then that would be the null hypothesis. So accused assumed to be true unless convincing evidence proof he has. Otherwise, he is considered as an innocent. So the alternative hypothesis will be guilty, right? So accused can be either be innocent or he can be guilty, right? So if he is innocent, then his null hypothesis will be innocent. That will be the null hypothesis, and alternative will be guilty. Okay. More example will be in actual research practice. If you say expectation about the parameters you are interested in will be your alternative hypothesis, and the opposite will be always your null hypothesis. So always assume that what anything that is opposite of your alternative hypothesis will be your null hypothesis. So more example you can take is, let's say less than 3% of all Americans have scuba diving experience.
Okay.
So we know that less than 3% of all Americans have scuba diving experience. So what would be your null hypothesis will be your 3% of population had scuba diving experience, and alternative will be 3% of population, less than 3% of population have scuba diving experience. So this will be always less than equals to. So null hypothesis will always be equals, and alternative hypothesis will be less than or greater than or not equals to. So we can have these three. Can be the less than or greater than or not equals to. What your null hypothesis will always be equals to. Okay. Another example would be, let's say the mean the mean maximum depth American drivers have ever reached is not 25 meter. Then alternative hypothesis will be not 25 meter, and null hypothesis will be equals to 25 meter. Okay. So how to conduct significance test? So now we know to distinguish null and alternative hypothesis. The next question we'll have is how to conduct significance test. So let's say how many Americans have scuba diving experience, and we know that less than 3% have scuba diving experience. So how we would write is this null hypothesis would be this would be equals to 0.03, and alternative will be less than 0.03. Now what we need to do is we need to conduct a significance test. So significance test, we assume that the population value have a certain value, the sample. So we know that from population we can derive sample value, right? So once we derive sample value through sampling distribution, so we have discussed this, uh, how we can draw sample is through simple random sampling sampling technique. So this technique we draw sample from population, right? Also that is also part of sampling distribution. Okay. So based on sampling data, sampling distribution, we we calculate test statistics. So test statistics will be, so so if here is the point of my null hypothesis and here is the point of the value that we are trying to assume, then the difference of that will be, this difference will be my test statistics, which also means the number of standard error sample value is removed from null hypothesis. So this distance, the number of sample standard error is what we call test statistics. So to compute significance test, we need to calculate test statistics. Okay. So let's say if my sample is of 1000 people and my proportion is 0.02. So how likely is our sample proportion of 0.02 if the population proportion is 0.03? So here what it is given is, if my population proportion is 0.03, what how likely is my sample proportion to be 0.02? This thing we need to test. So what we know, my null hypothesis will be my pi is equals to 0.03. Alternative hypothesis will be pi is not equals to 0.03. And we need to test how likely is the sample proportion 0.02. So given population proportion of 0.03, can we conclude that my sample proportion is 0.02? We need to test that. Okay. So what we need to test, given population proportion of 0.03, is sample proportion equals 0.02. This is what we need to test. Okay. So my population proportion will be always be the null and alternative hypothesis. So null hypothesis will be, if your population time proportion is equals to 0.03, that would be your null hypothesis. If your population proportion is not equals to 0.03, that would be your alternative hypothesis. So in a graph, if you look here, null hypothesis will always be your mean value. So 0.03 is given, your population proportion is given, and 0.02 will be somewhere on the left side of this graph. So this will be a sample value. So we need to test the given population proportion of 0.03 is my sample proportion 0.02 or not. Okay. So this difference is what we call test statistics, and this is what we need to compute. Okay. So any question here, Javaria? Is this clear? Hello.
Yes, sir. What did you say last point, sir?
So here what we need to do is, given a population parameter, population proportion, okay, so my population proportion will always be null and alternative hypothesis. Okay, so what would be null hypothesis? It's always equals, and alternative will be not equals.
Okay.
So given population proportion of 0.03, is your sample 0.02, how likely it is, that we need to test. This is what we need to test.
Okay.
Okay. So if you look at a graph, in a graph, your null hypothesis will always be a center point here, center mean.
Okay. I'll always be the center point. Mean.
Yeah.
Okay.
And your sample proportion is 0.02, which means somewhere left through your mean will be your, because it's 0.02, and we can say that it should be in somewhere
Hmm.
left side,
Hmm.
right? So
Okay.
here let's say here it's 0.02, then this difference is what we need to compute. Okay, this difference is what we need to compute, and that is what we call test statistics. Okay, which is also called number of standard error. The sample statistics is removed from the assumed population parameter. So this is the formula we have. So this is the similar to Z score, which is P minus, this is H naught divided by SE of SE naught, standard error. So your pi naught is 0.03. This is the proportion, population proportion, and your P is equals to 0.02. Okay, this is given here. Okay, P is 0.02. So if we substitute this value here, so we get z value of minus 1.85. Okay, so if we substitute p equals 0.02 and pi naught equals 0.03, and se, once we calculate this, it's equals to 0.005. So if we substitute all this value here, we get z is equals to minus 1.85. Okay, so here at this point your z score will be 0, because your p and pi naught will be both equals to 0.03 here at this point. At this point it is 1 point minus 1.85. So here what we, after substituting the value of p, pi naught and se,
Hmm.
we got minus 1.85.
Okay.
Okay, so we have a z score table also in R. In R we can compute this. So we need probability. So we need to use p norm. If we
Okay.
use p norm bracket minus 1.8, how much it was?
So did you upload this data set already in R?
No, right now I'm just checking for a particular value. I'm not using
Okay,
any
okay.
data set. So 1.80 of 1.85 we got, right? We got z score of minus 1.85. So if we run a p norm, gives you the probability. Okay, so that is 0.032. Okay, which is this value 0.032. Can see, you can even use using jet table. This is the jet table, you can find it in internet even. So
Mhm.
your, but in R, if you want to compute, you can use pnorm. Okay, so you got your pnorm of 0.03. Okay, here you can see 0.032. Okay, so your probability is 0.03. Okay, 0.03, the jet value probability. So 0.03 is what we call a p-value. Okay, so right now what we got 0.03, 0.0322 for z score of minus 1.85, right?
Yeah. Yeah.
We got, so this probability is called p-value. Also we call it as p-value. So what is p-value? This is the probability of test result, is the probability of test result of how how extreme the observation matches the actual observation given your null hypothesis is true. This is the definition of p-value. So if you look at the score, z-score of minus 1.85, 0.0332. So 0.0332 is your p-value. We usually term this as p-value. Okay. So remember, whenever we look at the jet table and whatever value we get, that is your p-value. So like I said, your significance level will have some threshold value, so that we can
Okay.
even, yeah, we can reject or accept our assumption, right? So significance, we have a cutoff of 0.05. Okay, significance level we call that as alpha 0.05. Okay? 0.05. So whatever p-value we get, if my p-value is less than 0.05, okay, then we fail to reject. Is less than 0.05, then we reject null hypothesis. That's not proof.
Okay.
We reject null hypothesis. If it is greater than 0.05, then we fail to reject null hypothesis.
Okay.
So here what we have, your p-value is 0.03, which is less than 0.05, right? Which is less than 0.05. 0.05 is your threshold value, level of significance, threshold value.
Yes.
This is level of significance. So we reject null hypothesis here because it is less than 0.05.
So, sir, if it's less than 0.05, so we don't need to do any hypothesis. Yeah?
No, what does this reject hypothesis means? Reject null hypothesis, which means, so we had two assumptions, right?
Yes.
What was why? So we had two assumptions. Your null hypothesis is equals to 0.03. The alternative hypothesis is not equals to 0.03. So you reject your null hypothesis here. You reject
Okay.
your null hypothesis. That means you accept your alternative hypothesis. Accept
Okay.
alternative hypothesis. Alternative hypothesis. Right? What does this means is
Oh,
the population parameter is not equals to 0.03. So what were we testing? We were testing here. The sample is your sample proportion of 0.02.
Sorry,
How?
sir. What did you say? What did you ask?
So here what we got.
Your
Mm,
so your voice is breaking up.
okay. So so this thing is clear, right? So we reject null hypothesis, right? So is this clear why
Yeah,
we reject null hypothesis? Because your p-value is less than 0.05.
yeah.
Okay, if it is 0.05, less than 0.05, we reject null hypothesis.
Okay.
That means we accept alternative hypothesis,
All
right?
right. Okay. Yeah,
Which
that makes
means,
sense.
yeah, which means your population parameter is not equals to 0.03. Okay, so what would be your conclusion? So also, if you reject, also if you look at, so here what we have, so we reject null hypothesis, right? Also, uh, here what you can see is, you can see is this point is your 0.05 interval. So this is your normal distribution bell shape curve, right? This is normal distribution bell shape distribution curve, right? So here this portion is your 95%. This one here we have already studied here. This percentage is your, so if you take both side, it will be 0.025 and 0.025. This plus this will be 0.05. If you take one side, then it would be your 0.05. So anything that is less than 0. This is your rejection region. What we even call this as a rejection region. Okay, so 0. In 0.05 we reject null hypothesis, right? Null hypothesis. Yeah, so that is often called the rejection region. Okay, so your rejection region is minus 1.64. How does this came is? So if you go in R and if you do Q of 0.05, Q gives you the quartile, like which quartile your 0.05 lies. So you can see minus 1.644 here. Okay, so this is what we get here, 0. Minus 1.664, and our Z score was minus 1.85 that we calculated. So here we can
Yeah.
clearly see that it lies in rejection region, right? It lies in rejection region.
Yes, sir.
Okay, so what we can conclude is, so we accept null alternative hypothesis. We accept alternative hypothesis. That means your population parameter is not 0.03, we can say. Okay, so what was our assumption? What were we checking? We were checking if how likely is our sample proportion of 0.02 if the population parameter is 0.03. We were checking that, and we found out that the population parameter will not be 0.03 given your sample of proportion is 0.02, right? That's what we found out. So this is, so here we did equals 0.03 and not equals 0.03.
Mm-hmm.
This is also called two side two side test. Okay, so why it is two
Two
side?
side test.
Yeah, why it is two side test? Because we are checking all condition that is not equals to 0.02, 0.03. Okay, so if 5 is greater than 0.03, then this is one side test. or if your 5 is less than 0.03, then this is also your this is one side right test. It's less than 0.03, this is one side left tail test, right tail test. So we can even see in this graph, not equals, if pi is not equals 0.03, this is your, you are testing both side. This would be your two tail test. If you are testing greater than, pi is greater than 0.03, that means you're testing only greater part here, this part, right? So this would be a one side test. Less than means one part, only one part you are testing. Okay, so that's why that is called one-sided, two-sided test. Okay, so we will do more example here. We will do the more example in R. So let's say we have another example here. So how many Americans have scuba diving experience? Let's say less than 3% have. We know that less than 3% has scuba diving experience, but test we need to test this assumption. This is what our intuition is like. We are guessing that less than 3% have, the less than 3% might have scuba diving experience. This is what we need to test. So since this is less than 0.03, this is one-sided. This is one-sided test, right? So this is one side of the sampling distribution. One side means here, this side, 0.05. This one side, because it is less than. If it is greater than, then this, it will be this side. Okay. So do you have any question regarding what is null hypothesis? Why do we use alternative hypothesis?
Oh no, sir, it's clear.
Yeah, test statistics, p-value. We have lots of terminology here.
Terminologies, yes, sir.
Yeah, level of
Sometimes
significance.
it's confusing if you don't do by comparison, like what is what, so you
Yeah,
can, I think so, get confused easily.
yeah. So one-sided test, two-sided test. So these all things you need to keep in your mind. Two-side test. Okay. So how many Americans have scuba diving experience? So let's, if it is, so here this is one-sided t-test, one-sided test, sorry, one-sided test, and the proportion is here because this is less than 0.03, means it lies here. Okay. So if it is not equals 0.03, this is two-sided test, two-side test, which means two side here. One side is this, one side is this, two side. And your proportion is divided into 0.025, 0.025. So if you had 0.025 plus 0.025, so total will be 0.05, right? So this is your two-sided test. In two-sided test, your probability will be 0.025 in both sides. So in this case, like if it is not equals to 0.003, okay, you, and if you are doing a two-sided test, right? So we got our z score of minus 1.85, right? And it does not lie within rejection region. So we cannot reject our null hypothesis that pi is equals to 0.03. So here we rejected the hypothesis. Here we rejected because we were checking only one side, right? We were only checking one side, that is less than equals to 0.03. Here in this example, we were checking only one side. But if we check both side, then your minus 1.85 does not fall in rejection region, because if you said, if you check both side, then your probability changes from 0.05 to 0.025 on both side. Okay, and we don't reject our null hypothesis, and we assume that this assumption is correct, like population mean is 0.03. Okay. So significance, your assumption varies depending upon your one or two tail test. Okay, so these are most significance tests are two side. So generally we do two side test because we don't know whether the population has experience in scuba diving or not. So simply we do not equals and we test the hypothesis. If we do not equals, that means we are doing two-tailed test, and my significance will be on that basis will be 0.05, which will be distributed in both end. Like this portion will be 0.025 and this portion will be 0.025. So based on one or two-tailed test, your result changes significantly, because in two-tailed test your p-value will be 0.025. In one-tailed test your p-value will be concentrated in one area, one part, which would be equals to 0.05. Your p-value will be, threshold value will be 0.05. So this varies depending upon one or two-tailed test. So this was on the basis of proportion, like out of 100%, 3%, whether they had experience on, whether they had scuba diving experience or not. This was on basis of proportion. Okay, so right now what we did, Z score was on the basis of proportion. So whatever we did, it was on the basis of
Okay.
proportion. Okay, so another is on the basis of mean. So if we have a population mean, so let's say now we are dealing with mean. So how long can a scuba diver stay underwater? If we have this question, then it may depends upon the depth of water, his experience, and several other factors. So let's say experienced driver will stay underwater for more than 60 minutes. Okay, and we have taken a sample of 100 people, and we say that 62 minutes experienced diver can stay inside water. Okay, 62 minutes, and we have a deviation of 5. This is standard deviation of 5. So whenever we have sample mean and we have sample size, then we deal with, so what would be in this case, what would be my null hypothesis will be. So what we need to do, the experienced driver will stay underwater for more than 60 minutes or not. So more than 60 minutes will be your alternative hypothesis, and equals to 60 will be your null hypothesis.
So it is not, it is a two-tailed test or one tail.
So if it is greater than, then this is one-tailed test, one-tailed. If it
Oh,
was not equals, then this would be your two-tailed test.
okay.
So why it is one-tailed test? Because the question is saying the experienced driver will stay underwater for more than 60 minutes or not. We need to test that, right? That's why we did here greater than 60. So again, your null hypothesis will be in the center point, 60, and your sample mean is 62 here. So 62, you can see the question is given, your sample mean is given here 62. Okay, so 62 will be somewhere here. Again, this is one-tailed test, one-tailed test. So we need to calculate test statistics here. What does test statistics means? That is the number of standard error sample mean is removed from null hypothesis. So here we don't know, to compute SC we need to know the population standard deviation. We don't know the population standard deviation. So we estimate population standard deviation. For estimating population standard deviation, we introduce extra error that is called t distribution. We don't use Z score here because Z score is only used for proportion of data. So out of 100%, 70% success. So whenever we have a proportion of data, then we use Z score calculation. Z score calculation. But when we have a sample size of, let's say, 50, 60, and we have given sample standard deviation of 5. So whenever we are dealing with sample mean or population mean, we calculate, we employ t distribution. So here, what would be my t distribution will be, we will use test statistics will be this formula. So finally, I got my t equals 4. If we solve this, 2 divided by 0.5, which means 20 divided by 5, that is equals to 4. So my t is equals to 4. So R, in R, for t equals 4, so we need to use pt to calculate probability of t score. We use pt of 4. So this pt of 4. And we also need to give my sample size, degree of freedom. What is the degree of freedom will be n minus 1. So my degree of freedom will be n minus 1. N is 100. So 100 minus 1 will be degree of freedom. 99, let's say. So your p-value is 0.99 here, based on t distribution. So 0.99 is your probability p-value. Okay, this is your p-value. Also, so how did we get 1.67 is, this means 95% of the population, right? So to get this value 1.67, we will do here qt. If we do qt of how many percent, it is 95, 0.95, 0.95. If we do 0.95 with 99 degree of freedom, 100 minus 1, so 1.66, 1.67 we get. So this is anything that is beyond 1.67, this would be my rejection region.
Okay.
So my t is 4, so we got t equals 4 from this formula. So this would be 2 divided by 0.5, that would be 20 by 5, that is equals to 4. So t is 4. Now it lies within the rejection region. Okay, so we reject null hypothesis, right? So if it lies within the rejection region, then we reject the null hypothesis. What was my null hypothesis? Null hypothesis was, so this was your null hypothesis, that your population is equals to 60, right? So we reject this assumption and we say no, it's not equals to 60, it's greater than 60. So experienced driver who stay underwater is more than 60, provided your sample is, if you check for 100 sample, if its mean is 62, then, and standard deviation is 5, what you conclude, yeah, that your your average driver who stay underwater is more than 60%, because we reject our null hypothesis, right? Reject the null hypothesis. So this is a right tailed test, because we are my null hypothesis is greater than 60. Okay, so for left tailed test will be less than 60 will be left tailed test, and not equals 60 will be two-sided test. Okay, so we can even look at t table. In t table, if you look for 60 degree of freedom, why we choose 60? Because degree of freedom will always be n minus 1. So degree of freedom will always be n minus 1. So n is 100, 100 minus 1, that is 99. So closest to 100 to 90, 99 is 60. That's why we chose 1.67. Okay. So what we can say? So we reject the null hypothesis. On an average, experienced drivers stay underwater is more than 60 minutes. This is what we conclude, right? So this is what we conclude, that on
Yes.
average, experienced driver stay underwater is more than 60 minutes. So we will have two cases, right? So first case will be whether the experienced driver will stay under water for more than 60 minutes. So this would be my first case. Null hypothesis, alternative hypothesis we will have. And other is whether my experienced driver will stay underwater either more or less than 60 minutes. So this will be a not equals to 6, because it can be either more or less. So if this will be my two-sided test, this will be one-sided test. So let's say if null hypothesis is 60 and alternative hypothesis is not equals to 60. Okay, so that would be your two-tailed test. Okay, so we can adjust our level of significance. So we generally consider level of significance equals 0.05, but
5 years.
yeah,
So
so
this
but
0.05 is the general, like, standard.
yeah, that means 95%.
5% per year in the
Yeah, we are confident that
in our
yeah,
decision, whatever the result is.
yeah. So we can change this level of significance to 0.01 even. As per our requirement, we can change and can test the assumption. So if we do 0.99, which is we are taking a significance level of 0.01, then you get this value here, right? So how did we get minus 2.66 is, if you look at, so if you look at here, qt of, now uh, your proportion is 0.005, so qt of 0.005, if you check maintain freedom, so it's minus 2.62, right? So this region is minus 2.6 somewhere here, and and we have got t equals 4, which lies inside the rejection region. So we can still reject null hypothesis even if we chose our level of significance as 0.01. Okay, so what would be your conclusion? So mean time experienced American driver with an average strength at an average depth stay underwater is not 60 minutes, it's greater than 60 minutes or less than 60 minutes, because we reject our null hypothesis. Our null hypothesis is equals to 60 minutes. Okay. Yeah. Does this make sense? Okay. So
Yes, sir, it is.
yeah, so we discussed about two things, right? One is based on proportion, one is based on mean. In proportion, we compute Z score. On mean, on sample mean, we compute T distribution, right? So this, so given a problem, we need to able to distinguish whether it's a proportion or it's a mean. This is one of the first tasks when we do hypothesis testing. Okay, so here, let's say example here. More than half of all the certified drivers in America have more than 35 hours of driving experience. So more than half, it is talking about proportion 0.5, right? So here we will compute Z score. Okay, and in second, mean number of more than half. Okay, mean number of hours of driving experience of all certified doctors is in America is more than 35 hours. So here it is talking about mean. So here we will compute T distribution. Okay, so this would be my T distribution and this would be my Z distribution. So whenever we're talking about mean, then we compute T distribution, and whenever we are talking about proportion, then we talk about Z score. And in the first example, we are talking about proportion more than half. So so we will use Z score. In second, we are talking about mean number of hours. So we will use T score, T distribution. Sorry. So so this is one of the way we identify whether it's proportion or mean distribution. So step by step plan to conduct hypothesis testing would be, so first we need to determine whether it's proportion or mean. Okay, so in first example was my proportion and second example was mean. Okay, so let's say in first example I have a proportion of 0.57 and in second example I have mean of 35.5%. Okay, and second would be to formulate hypothesis, which means what will be my null hypothesis here. Okay, formulate hypothesis, null hypothesis will be null will be equals to, if more than half means it is equals to 0.5 and alternative will be greater than equals to 0.5, and this is the right tailed test because it is greater than here. And in case of mean, it will be if it is equals to 35 or if it is greater than 35. This is also right tailed test. Okay, and third one would be to check assumption. So in case of proportion, if your sample size is greater than equals to 15, and in case of mean, your mean is randomly distributed or not. So if your mean is approximately normal or not, if it follows the bell-shaped curve or not. So we need to check that assumption. Fourth is
Okay, sir. Yeah.
yeah, fourth is to compute your alpha. The alpha means your level of significance, right? So level of
Yes, sir.
significance, whether we are choosing 0.05 or 0.01
Yes, sir.
or 0.01, we need to have that in mind. Then we need to compute test statistics. So in this example, it would be my Z score, and in this example, it would be T distribution because this is my mean, this is my proportion. And then we need to draw sampling distribution here. So this is right tail test, right tail test. So it will be 0.05, and it will the rejection region will lie somewhere here. It will lie somewhere here. So we need to draw this sampling distribution. and find location of t-test. Okay, so z score is 0.3.13, which is greater than your rejection region, so you reject your null hypothesis. Okay, so here your t distribution is 1.4, which does not lie in the rejection region, so you don't reject your null hypothesis here. So here you don't reject, no, and here you reject, because here it lies within your rejection region, here it doesn't lie within rejection region. And finally we interpret our findings. So here what we can say, we cannot conclude that the mean number of hours of driving experience is more than 35 hours, because we are rejecting our null hypothesis, which means we are in favor of alternative hypothesis. And here we are accepting null hypothesis, which means all certified doctors will have more than 35 hours of driving experience. Okay, so this was my null hypothesis. This was the assumption that we made. So these are the 9 steps that we need to follow when calculating hypothesis testing, when doing a hypothesis testing. Okay, so any question
Yes,
here?
sir. No, no, sir. Really tired.
So in last week we discussed about confidence interval as well, right? So confidence interval and your significance test, hypothesis test, both relate each other, because the target is to find population parameter, right? So looking at the sample, if we draw a conclusion of population parameter, that is what our aim is. So that aim is fulfilled through significance test, which is hypothesis testing, right? And even through confidence interval. So how can we how our estimation and confidence interval closely related is, let's say this example here. So we have, so my n is 500, mean is 36, standard deviation is 8, null hypothesis is equals to 35, not equals to 35, we calculate t as 2.80. So we substitute this value here and we calculate t as 2.80, and 2.80 lies within rejection region, and we can say that the mean number of driving hours of certified scuba indeed differs from 35, because we reject our null hypothesis because it lies within rejection region, so we reject the null hypothesis. That is, we conclude that the mean number of differs from 35, so we're in favor of alternative hypothesis, this one, right? So this is the hypothesis testing that we do on the basis of confidence interval.
Mhm.
Here this is the formula to generate 95% confidence interval. So we can say at 95% confidence interval, your value lies between 35.29 to 36.71, right? What was my null hypothesis? Null hypothesis was mu equals 35. Alternative
Yes,
was mu not equals 35. So here we
fine.
can, here we can clearly see that it is not equals to 35, right? It lies within 35 to 36. So
Yes,
we are in favor of alternative hypothesis, right? So confidence interval also gives us the indication that whether we should be in favor of null hypothesis or in favor of alternative hypothesis. So through confidence interval also find we can do our hypothesis testing. Okay. So this is what we conclude here. Conclusion is it differs. Another thing is type 1 and type 2 error. What does type 1 and type 2 error means is, suppose for an example, defendant is innocent and he has been set free. So accused is innocent and he has set free. So he he got an approval of he can go home, he is set free. But the defendant is guilty and he is convicted because is guilty, he has been convicted, right? So what happens is, if a person is innocent, if a accused is innocent, but he is not set free, so here he has set free, right? But he, if he is not set free, then this is a type 1 error. Type 1 error. If we know that the person is guilty, person is innocent, however he has not been set free, he is convicted, then that is type 1 error. If the person is guilty, right, but he has been set free, right, he has been set free, that is called type 2 error. Type 1, type 2 error. Okay. So one more one example can be, suppose for example, one example can be, he's an old man, right? So we know that he's an old man, he's not pregnant. But a type 1 error example can be, like, we know that he's a person, he will not be a pregnant, but that would be a type 1 error because we know that he is not pregnant, but people say that he's pregnant, then that is type 1 error. And type 2 error means she is pregnant, but the person says like she's not pregnant, then that is your type 2 error. You can relate this with similar example. If a person is innocent but he has been convicted for a crime, then that is your type 1 error. Type 1 error. And he is guilty, but he once he is set free, then that is your type 2 error. So
Okay.
if your S not is true, but even he's rejected, then that is type 1. If S not is false and he's not rejected, then that is type 2 error. So these are all terminology that you need to remember. Okay. Yeah, so that's it for Null and Alternative hypothesis. So any question you have? You understood everything what if I told you?
Yes, sir. Yeah, pretty much all. But when I will go through again the lecture, so then it will make more sense.
Yeah.
Hopefully.
Okay. So we will implement all this in R. So let's take 5 minute break and then we will start the implementation in R. Then this will even give you more more clear picture of how this is done. Okay, so let's take 5 minute break then. Okay.
Okay, sir.
Okay.
Are you back, sir?
Hello. Yeah. So the file is in here in week 7. So I will be using hypothesis testing.r file. Okay. So what we have learned. So if my p-value is less than level of significance, okay, which is 0.05, 0.05. Okay. So p-value less than 0.05. Also, your test statistics that we have calculated is greater than tabulated value, whatever result that we give. Right? So in that case, what we do, we reject our null hypothesis. That means we don't accept null hypothesis. We reject hypothesis if my p-value is less than 0.05. We know that. Okay.
Okay.
So if it is greater than 0.05, which is level of significance, then we fail to reject null hypothesis, right? We fail to reject null hypothesis. So these two rules we should always keep in our mind. Okay. So one way is this. Another way is I have shown you through the test statistics. Even we can find out like through test statistics. So, for example, after computing test statistics here, we got Z score of minus 1.85. Okay, then we looked at rejection region, right? So it lies within the rejection region. It lies within rejection region. Then we reject no hypothesis. So in that way, even we can through test statistics, even we can compute. We can say whether we should reject or accept the hypothesis. So let's consider an example. Uh, Consider a survey asking 100 randomly selected people if they had breakfast on Sunday morning. This was the example which I told you previously. So consider a survey asking 100 randomly selected people if they have breakfast or not. Okay. Suppose 42 people say yes. Does this support the hypothesis that the true proportion is 50%? So given a data where 42 people say yes, so what can we say, like it's a 50% proportion or not? This is what we need to test. Does this support the hypothesis that the true proportion is 50%? This is what we need to test. Okay. So this right now, if you look, you will say that 42 people out of 100, which is less than 50%, right? So it will definitely not, right? You will say it will definitely not. But uh, to prove this, we do statistical testing, right? So statistical testing also work when numbers are very close. Let's say, okay, 49, we have 48%, and suppose we have 47.66 or 49.6688. If we have two numbers that is very close, and we are not sure whether the one number is true or not, in that case even we do a hypothesis testing, right? So here in this example, what we need to do, we need to do is it a proportion or mean? In this example, is this a proportion or mean? First we need to figure out as per as per the step by step. The first thing is determine the proportion, whether it's a proportion or mean. So what do you say? Is it a proportion or mean in this example? हाँ Chabadia? Chabadia, are you there?
Oh, yes, sir.
So is this a proportion or mean? This example.
So, consider survey. Okay.
So first step would
So
be
it's mean, sir. Is it mean, sir?
how?
So because it's saying the 50%, the true proportion is 50%, because we took the sample of 100 people randomly.
So it says true proportion is 50%. This means this is a proportion, right? Not sample. Not
Okay.
sample. If
Me.
my question was something like this, like mean population of an hour of driving, if the mean it is given, then that is mean. If it is given in proportion like half or quarter or 50%, 20%, then that is proportion. Yeah. So does this support the hypothesis that the true proportion is?
Okay.
So this would be your proportion, right? So first step we have figured out that
So
it
it's
is a
gonna be an
proportion.
example.
So this example is a proportion, right?
Okay. Right.
So first step we have figured out. Second step is to write null and alternative hypothesis. So here what would be your null and alternative hypothesis? So null hypothesis will be if the proportion is 0.5 or not, will be your null hypothesis. If the proportion is 0.5, what will be your alternative hypothesis? Proportion is not equals to 0.5. Okay, that would be your null and alternative hypothesis. Then third one
Okay.
is to third one is to check assumption. So here we know for proportion your assumption n should be greater than equals to 15, right? So our n is 100. So this third assumption has also been made. And fourth one is to determine alpha. So we will choose 0.05 and then compute test statistics. Okay. So to compute test statistics for proportion, what we do is we use test dot we use prop dot test. So if we do prop dot test, here you can see x and p is everything is given here, right? So your x will be here. So we have 42 people, 42 people who said yes out of 100 people, right?
Okay.
X,
Yeah.
X, and then third one would be, so even if you do question mark and test proportion here, if you type, then you will have the definition of what proportion dot test means. Okay, so here X will be your number of people who said yes, and
Yeah.
n will be total number is 100,
Yeah.
and p will be p is
Your
given
proportion
your proportion, which is 0.5
zero
comma.
zero.
Okay, so this is whether this is my left tail or right tail, or two side test or one side test. So here which test is this?
So it would be two tail test.
Yeah, yes, this is two side test. Yeah, two side. Okay, two sided. Okay, and what would be my confidence interval?
So is there
Confidence
any difference between two-sided or two-tailed?
two-tailed, two-sided, both are same.
Okay.
Confidence interval is 0.95. Okay, and last parameter, this is by default. Let's say this is equals to true. So if you run this statistics,
Yeah.
alternative equals C bracket 2 dot, should be 2 dot sided. You can see here it's 2 dot. So here what we
Yes,
can
sir.
see. So this is one sample test, one sample proportion test we are doing, because we are looking at one sample. Okay. So
Okay.
this is one sample proportion test. Here out of 42, what we got p value is 0.1336. Okay, so if p value is less than 0.05, we reject null hypothesis, right? So here the p value is greater than 0.05, which is 0.1, right? 0.1. So what do we need to, what would be your conclusion? Whether you
So
reject,
then we will reject
so
the null hypothesis and accept alternative.
yeah, so we reject a null hypothesis. No, because my p-value is, so here you can say p-value greater than 0.05. If your p-value is less than 0.05, you reject
Then we
null
will
hypothesis.
reject.
Null hypothesis.
Okay.
But your p-value is greater than 0.05 here at 0.1, right?
Okay.
So you accept null hypothesis, which
Okay.
means you fail to reject null hypothesis.
Okay.
Okay. So what would be my conclusion?
So we accept the null hypothesis and reject alternative.
We accept null hypothesis. Also, we can say we fail to reject null hypothesis. Right? Both are same. We accept null hypothesis, or we say we fail to reject null hypothesis. Right? So what does that mean? What does that mean? So your proportion is 50%, right? So
Yes.
so we can say that it is equals to 50%,
Yeah.
right? So let's take another example. So so and also we can see here the confidence interval is between 0.32 to 0.52, right? So yeah, looking at confidence interval, we can even say that we accept null hypothesis. And another will be, let's say if we increase the number of people to 1000 and your sample value to 420 in this figure, in this distribution, your sample is 420. Let's say your population is 1000 and p is 105, and you do two tail tests. So here your p value is this much. What does this mean? Your p value is this much. So you increase your people and proportion.
Yeah.
So previously it was 42, you increased it with 420. Previously it was 100, now you increase it with 1000.
1000. Yeah.
So your p value is this much, which is very much less than 0.05, right? So if it is less than 0.05, so we reject null hypothesis.
Yeah.
Okay. So what would be your conclusion here?
So is it 4.9?
Yeah, this e to the power, this means 0.0000049944.
Oh, okay.
So conclusion is
So
we
we reject the null.
reject null hypothesis. Means we accept alternative
Alternative. Yeah.
hypothesis. And what does this mean? The proportion is not equals to 0.5, right? And what was in this case, what would be your non-alternative hypothesis? Null hypothesis will be if your proportion is equals to 0.5, alternative will be not equals to 0.5. So what would be your conclusion? So your true proportion is not equals to 0.5, right? True proportion is not equal to 0.5 because
Yeah.
we reject null hypothesis and we accepted alternative hypothesis. Okay. Now Uh, so we have another question here. Suppose a flash light manufacturer claims a customer got 25 hours of light on average on a full charge. A customer group asks 10 owners of the flashlight to calculate their hours of uses on a full charge, and the mean value was this much and standard deviation was this much. Okay, so suppose a flashlight manufacturer claims a customer got 25 hours of light or not. This is what our assumption is, and he did a sample of 10 owners, and he checked that the average value was this much and standard deviation was this much. So what would be your null hypothesis? Your mu is equals to 25 or not. Okay, and alternative hypothesis is mu is less than or equals to 25, because on basis of 10 owners we find out that his mean was 22, right? So of course it would be less than 25. So that's why your alternative hypothesis is mu is less than 25. Okay, so this is your proportion or t-test. So this is a t-test, right? Because here we are talking about proportion. We are talking about mean.
Yes, sir.
Okay. So so your x bar, let's say this is your sample. The sample is 22. Okay. Standard deviation is given 1.5 is given. Your number of rows is given here. How much? 10. So we will use t statistics formula here. So test statistics formula will be x bar minus mu naught divided by SE. Okay. So x bar minus mu naught. So mu naught is 25 hours given here is 25 divided by standard error means S divided by SQRT of n. Okay. So this will give me t. So it is minus 6.32. So if we calculate the p value of t comma, my degree of freedom will be n minus 1. If we compute this, so your p value is minus, it is e to the power something means 0.000000684, which is less than 0.05, right? So what would be your conclusion? Conclusion will be we reject null hypothesis, except alternative hypothesis.
Mhm.
Because p value is less than 0.05.
Okay.
Okay. So here we calculate this manually because we didn't had the sample data, right? Because
Yeah.
we knew our x bar, so we did t. We need to calculate t. So
Mhm.
if we have a sample data, then we can use a similar approach that we did for proportion.
Mhm.
So suppose if my data is something like this. So if it's a result something here. So here again do even t test t dot test. So if we look at the syntax of t-test.
Mhm.
So it's x, this, it follows this. So x is the result, comma, here this is, we have 6 randomly selected member of a population whose distribution is
Yeah.
given here. And test hypothesis, it will be 14, and alternative will be greater than 14. This is given.
Yeah.
So equals to 14. This, the alternative, this will be equals to greater, because here we are talking about greater than equals to 15, 14. Yeah. So if you run this, so here even we can get the result all at once, and p-value is 0.02, which is less than 0.05. So we reject null hypothesis.
Yeah.
This, yeah. Hmm. So two sample test for proportion. So right now whatever we did was for one sample. One sample we compute the t-test and z-test, proportion
Yeah.
test. So right now, if I have two sample tests, suppose two sample, for example, would be a survey is taken 2 times over the course of 2 weeks. So we have in 1 week 2 times it has taken one one test 45, another one test 35. In week two, again two sample was taken. Okay, so this is the example of two sample test. Okay? So in two sample test, how do we compute uh, testing is, so we do prop dot test. So prop dot test means this is the proportion. So x will be number of success out of total n. So my total number of success will always be, yeah, 45 comma 56, and total n will be always 45 plus 35, this one, and comma 56 plus 47. So this is the proportion. So here you can see p value 0.9. So which is greater than 0.05. So we accept null hypothesis here. So this is how we do two sample test, right? So two sample proportion test. If we have two data, like two sample data, then we do proportion test for two sample test. This is my two sample test. In a week, I have two data, 2 times it has done. Survey was done 2 times. Likewise, we even have two sample two sample tests for mean, two sample tests for proportion that we did here. Likewise, we have two sample tests for mean. Suppose here is the data.
Mhm.
Suppose the recovery time for taking a new drug is measured in days, and placebo group is also used to avoid the placebo effect. And we have this data here.
Yeah.
So this is a two sample mean test we are doing. Here we have two sample data. One sample is for which drug, another sample is for placebo drug. So based on these steps,
Mhm.
so we need to check the assumption even, right? So for
Mhm.
assumption, so this assumption should follow the normality curve here. It says, right? So for
Yeah.
which we have a box plot, box plot of with drug, comma,
Okay.
residue. So looking at box plot here, so we can say this data is normally distributed because in both 1 and 2 you will see it is
Mhm.
divided into equal half. The box plot is divided into equal half. So this looks normally distributed. Okay. So
Okay.
to calculate variance, we will use var of withdrawal and var of residue. So the variance is different, right? So here
Yes.
test t dot test bracket with withdraw comma residue comma. So alternative is less. So here we are checking whether the null hypothesis of equal mean against the one-sided test. So one-sided test means your drug group has a smaller mean. So this has a smaller mean than placebo. We are checking that. Yeah. var dot equal var dot equal because the variance is not equal here.
Yeah.
Yes. So we will do var dot equals false. So here we can see it's 0.5. So this is we reject null hypothesis because it is greater than 0.05, right? So sorry, we accept null hypothesis because it's less than 0.05. It's greater than 0.05. We accept null hypothesis.
So is it? Yeah, it is better than yeah.
Yeah, because it's greater than 0.05. So even if we do variance equals true, so yeah, we're getting the same result.
Okay.
Yeah, so this is not causing much difference here. So this was two sample test for me. Okay,
Mhm.
two sample test for me. Now the last one is uh, this one is paired test. Like one data depends on other. That is what we call a pair testing. A matched sample means one data depending on other. So for example, in order to promote fairness in grading
Mhm.
and entrance examination, this candidate was graded twice by different graders. To this candidate was graded twice. So the candidate was graded twice by two different teachers. Okay, so based on the grading, can you see if there's a difference between the two grades? So here we can see the candidate is same, right? The candidate is
Mhm.
the same, but the grader is different, right? So we can see the dependency of candidate because his result is same, but the grader
Mhm.
is doing grading on same paper. So we can see
Mhm.
that it is dependent. One is dependent on other. So
Mhm.
here what we need to check if this the mark that we got from
Mhm.
grader one is different from grader two or not.
Mhm.
That would be our testing. So here we will do here we will do a paired testing. Okay. So
Mhm.
before that we need to check whether the normality is met or not. So for
Mhm.
that we do that equals So we have QQ plot here, QQ norm. If we use now graded one, QQ norm. Okay. Then MF. So QQ line bracket greater one. QQ line greater than. So if you run this, then we can say this does not look normal because the line is not crossing each point. Mm, right? So we cannot say this as normal. Let's plot a histogram. Hist of grade one. Hist of grade two. So yeah, so this says left is skewed, this is right is skewed. Okay. So so this is the case. So we need to check the normality first, right? So here we can see the normality has not been met. Okay. So we cannot proceed with our testing because the data needs to be normal if we do our t-test testing. T-test. Okay. So
Okay.
yeah, so here we can see the normality has not been met, but we assume that if in case if normality has been made, then how would we compute is we use t dot test bracket greater than comma greater to, we use paired equals true. Okay, and alternative equals true dot sided. Okay, so paired equals true means that the one result is dependent upon other. It's paired. Okay, so we got this result 0.08, 0.08, which is greater than 0.05, means there is a difference between grade 1 and grade 2. Well, both the result is different, right? So grading the mark for the candidate of differ from one another, right? So there is a bias, we can say. One grader gives the candidate another marks and another grader gives them another marks. So there is a bias over grader. So this is even one testing that we can do if there is a paired testing. So yeah, so this is all what we can do in hypothesis testing. So this is often relate with real world, like we need a sample data and we perform testing, but in real life even we can do such testing. And researcher, statistician, they usually do this testing often. So yeah, so this was the end of the hypothesis testing that we do.
Okay.
I have also added a few quiz question for week 7 hypothesis testing here. So if you go through the slide and if you
So
look at,
that's these ones in week 7 here.
yeah,
If
it's
I'm
in
not
week
wrong.
7, yeah. So if you try to solve these questions, then if you practice by yourself, then yeah, it will make more sense. Okay, so yeah, that's it for today.
Alright.
Do you have any question?
No, no, yes, sir. Mhm.
Okay, so are you practicing or doing some practice?
Sorry, what
So,
did you say, sir?
did you do the practice for week from week 1 to week 6? Did you complete any work here? SQL in even here I have given you the assignment in week 8. I mean, week 7, I
No,
think.
sir, I haven't completed the assignment yet.
Okay. So for Tableau, I have uh, created a step-by-step tutorial. So did you check this? So if you follow these steps, I have done everything from scratch. So if you follow this step, then you can create this dashboard.
Dashboard. Okay,
Yeah,
all right.
this dashboard. So yeah, so try to complete this dashboard because you will learn a lot once you do, or if you implement
Mhm.
this by yourself.
Okay, sir.
So officially, like course is complete. One project for in Python is remaining, which we
Sorry,
have.
say it again, sir.
So officially, the course, as per the syllabus, we have covered
Mm-hmm. Mm-hmm.
everything,
Mm-hmm.
almost everything.
Okay.
So yeah, we have. So this was hypothesis testing was remaining that we did today.
Mm-hmm.
Yeah. Mm. So we have so one project is remaining in R. So that we will be doing. We were doing last week, and we will still continue tomorrow and next week. So I will be here to solve any questions, quiz questions, or any assignment problems you have.
Okay, sir.
So yeah. So
Sir, is
last
it possible, sir, is it possible that for because tomorrow morning I have work, so we can do on a Sunday evening?
we can do Sunday at 5:30.
Okay. Oh,
Okay, so Sunday evening, if you come, then in week 10, not in week 10, in week 9, we have
mm-hmm.
started, we have done a bit of analysis here
Mm-hmm.
for COVID data. So
Okay, sir.
have a look at this analysis that we have done
Okay, sir.
because we will continue from here.
Oh, so so we're gonna do on work on Python or Tableau?
So we will work on Python because in Tableau we are almost done.
Okay.
So in Tableau, if you have any question, try to replicate this dashboard. And
Okay.
if you have any question, then we can discuss in that time.
All right, sir.
But for project for Python project, have a look at once you start implementing this by yourself, and yeah,
Mm-hmm.
and see because we will continue from here on
Okay.
Sunday.
All
Okay.
right. Yeah.
So yeah, so we have last week. So one more week remaining.
Mm-hmm.
One class will be on Sunday, and then two more classes.
Okay. So, sir, do we need to complete our project for
Yeah, you need to complete your assignment, two assignment.
by next week or by this week?
Yeah, by next week, you need to complete two assignment and all quizzes.
Mm-hmm.
All the quizzes in R I have given in Excel. Even I have given one quiz and one dashboard for you to prepare. In Tableau, you need to complete this dashboard work. In DA using SQL, you need to complete this master join
Okay.
article. You need to complete. Okay. Try to do a bit of work, but if not, try to complete at least one part, either visualization part or Python part or Excel part. Try to complete at least one
Mm-hmm.
so that we can discuss. next week, because if you don't have any question, then yes, and then you will not have any work next week.
Okay. All right. Okay, sir.
Okay, then see you on Sunday then,
Okay,
5:30.
all right.
Okay.
So are you available before that as well? Like before
Um,
5:30 on Sunday?
so we can start from 5 if you want.
Or Saturday evening? No, Saturday evening we're having a preview. So it's all right for 5 o'clock for Sunday.
So we can start from 5, right?
All right. So, yeah.
Okay. Start from 5. Okay. Try to practice.
Yes, sir.
Yeah, it's been 10 weeks, right?
Yeah. It's almost we are about to finish everything.
Yeah, we are about to finish everything. No, this is the 11th week running.
Yeah.
11th week, yeah. Okay.
Um, all right.
Try.
See you
See you
on
on
Sunday.
Sunday.
Okay.
See.
Have a good
Thank you.
week.
Thank you. Bye.